So, financial economics is a subject where we try and understand how we are going to invest in various assets. Everybody is interested in finding out what is the best type of portfolio management that one would like, in which case we are trying to create various models whereby we get the optimization of what is it that one should invest. And in the case of investment, what we're trying to look at are two basic assets. One are what are known as risk-free assets, and the other is known as risk risky assets. So most people, what they will try to do is take a combination of the two. That is what we try and understand at a later level. What we're seeing now is the first one is simple and compound interest. Now, in the case of simple and compound interest, that is the money that you invest for 1 year, we get an interest for that period, which is R. So what we do here is that we get an interest which is R, and if we invest for 2 years, then what we get is 2R. So what we get is 2R. The value after n years is going to be what is written over here. V is equal to 1 plus Rn into A, where R is the rate of interest, N is the number of years, and A is the principal amount. All right, so let's start with simple interest, which means that, so what we are looking at is trying to invest for 1 year. And when we are saying 1 year, you get interest for only that period, and that period, the rate of interest is R. If we decide instead to invest for 2 years, then what we get is 2R. Now, this is known as simple interest, which means that what is happening is that the amount of money that you put in, for example, say a bank, earns a rate of interest, say 4%. Today, State Bank of India has reduced it to 3.5%. This means per annum. That's what you get, right? And what it means is that the rate of interest then currently for State Bank of India would be 3.5%. The number of years would be 1 year, and the principal amount would be whatever you put in your savings account, which may be 1,000 rupees. Right? So that is the amount of interest, and that is the simple interest type of thing that we are talking about. The next concept is that if you get interest for a fraction of the year, then what you get is something known as RT, which means that RT is that you might get the interest after 3 months, you might get the interest after 6 months. In India today, we get interest every 6 months. So what it means, it doesn't mean that you get 3.5% every 6 months. It means that you get approximately close to 2% every 6 months. So your total comes to close to 4% or 3.5% at the end of the year. That is what it means. So RT basically means that fraction. So it could be then written as 3 out of 12, or it could be written as 6 out of 12. It could be written as 1 out of 12. So the rate of interest could be divided in over 12 months in any which fashion. We next come to what is known as compound interest. Now, compound interest really means that what you earn is an interest. This is the most relevant portion. Interest on an interest. That means that the interest remains in the account and it earns an interest in the next year. Right? Now, when you're going to earn an interest in the next year, that means in the first year, the money is multiplied by what is known as 1 by R. And after the second year, it becomes 1 plus R into 1 plus R, which is equal to 1 plus R square. So after n years, it becomes 1 plus R raised to the power of n. This type of growth is known as a geometric growth. So what it means is that if I have 100 rupees and I'm earning a 4% interest on it, I get 104. This is in year 1. Now in the second year, I again get an interest, and the principal amount now becomes 104. So this is equal to 100 plus 4 rupees, which I earned as interest in the first year. In the second year, the 4% will be on 104. This continues for the number of time period that one is holding that money in the account. Now, if you plot it as a graph, what you can see is that definitely what we need to put on the y-axis is the value, and on the x-axis is the year. So the rate at which the money grows is much faster in the case of compound interest than in the case of simple interest. Because in the simple interest formula, you are just paid the same amount every year. So your basis is not on 104, it is on 100 as far as simple interest is concerned. But in the case of compound interest, it becomes 104. So definitely there is a difference between the simple and the compound interest. Please do understand that you have to label the y-axis and the x-axis. Never leave them blank, because if you do so, then in an exam you're going to get 0 for it. What is very interesting is what is known as the 7-10 rule, which means that money invested at 7% per year doubles in approximately 10 years. There is a formula to it. All you should do is understand it, otherwise it becomes very complicated to try and explain it to you. Similarly, you can look at it the other way. Money invested at 10% is going to double in 7 years. So this is a very interesting formula. The 10, so what is important to note here is the 10 and the 7, which is what we look at. Now, when you're looking at compounding at various interest values, very often you find that interest is calculated not at the end of the year, as I just mentioned earlier, but more frequently it could be quarterly, it could be monthly. And when you say quarterly, it means R by 4. That means it is applied every quarter. Here, R is the rate of interest, and 4 means that it is quarterly. And then you have, so what happens here is that after 1 year, it will be 1 plus R by 4 raised to the power of 4, right? Why 4? Because the year is divided into 4 bits. And then you find that 1 plus R by 4 raised to the power of 4 is greater than 1 plus R, which is very interesting, because the 1 plus R means that you're going to get the interest rate after 12 months. But here what you're going to do is that you're going to get the interest rate after every 4 months, right? And then what's going to happen is that you are then, so every time you get the interest rate, which is what the example is, supposing you have an 8% interest rate compounded quarterly, it will get us 1.02 raised to the power of 4, which means 1.0824. And the effective rate of interest becomes 8.24, while ideally it is just 0.8%. So it should be just 8. So you're getting this extra 2.4% because of the fact that interest is given and compounded quarterly. The term that is used is compounded. So it does not work in a simple interest formula. It works in a compound interest formula, and then you can rewrite it as 1 plus R over M into K, where M, as I mentioned earlier, is the number of months in a year, K is the number of years, R is the rate of interest, and 1 is the principal amount. Continuous compounding. So the third type of compounding is known as continuous compounding, which means that you find the limit. Now, when you're looking at the limit of 1 plus R divided by M raised to the power of M, which is e to R. So this obviously looks at the log formula, where M is going to move towards infinity. E is 2.7818. This is something which is given and taken. This is the base of the natural logarithm. Thus, continuous compounding, the growth would be E 0 raised to the power of 0.08, where 8% is the rate of interest. And what happens here is that it becomes even better, because in an 8% rate of interest, you're actually earning 8.33. The case would be similar for borrowing, because in this case, it is compounded monthly. Then after that, if we have to borrow it, then it moves to 1 plus r divided by 12 raised to the power of k. Thank you.